See you later. Thank you. You can be in shot, it's good. Locked and loaded.
This is Alpha 6, the full length 3-4 left. Alpha 6 autopilot thruster fill there.
Checked. So the departures course 1330 passing 1,200 over 5,000.
Hey folks, Greg Fitzgerald here. What a great day we're expecting. So the meteorologists are telling us that we should expect cloud in the northern part of the Transantarctic Mountains, but we're hoping that some of the larger mountains like Mount Minto will be sticking out through that cloud. We will have a bit of cloud further down the Ross Sea, but what they have guaranteed us of is pristine viewing past a place called Mount Melbourne, the Terra Nova Bay and the Drygalski ice tongue. And that's perfect because we should get, or we will get, great viewing down to the dry valleys, across to the large American base of McMurdo, the New Zealand base of Scott, and of course Mount Erebus, which is just absolutely spectacular viewing. Retrace our steps, do a few more laps of Mount Erebus and McMurdo base, back to the dry valleys, then work our way northbound again, exactly like we did as we came south, all the way back till we reach that cloud we talked about around Mount Melbourne and Terra Nova Bay. So we expect that we'll go a little bit further west than what we came in, closer to the Freiburg Ranges, and cross the coast just a little bit further west than the way we entered Antarctica. And then, of course, we're on our way back to Sydney. We're going to have a great day.
Are the hard workers?
How do you like it?
Oh, hi.
Actually, could I get another one?
Just saying we're doing the best part of 1,000 kilometres an hour towards the
Standing right next to me, I'm now a commentator on ships down here. Hey folks, it's Greg Fitzgerald. Welcome to Antarctica, the White Continent. The highest, the coldest, the driest, the windiest and the cloudiest continent on Earth. Going to have a great day's viewing down the Ross Sea. Hope you enjoy it. Just out on the left-hand side at the moment, which is going to get covered by cloud, so hopefully we'll get more glimpses of it this afternoon, is coming up. We're coming up to Cape Adare, which is the first recognised landing point of humans in Antarctica by Boykovich and Carson in 1895. And whilst I won't talk too much about it this afternoon, hopefully the cloud on our way out will be a little bit better. And there are 2 huts down there which were the first man-made structures erected in Antarctica, but just a little bit of cloud over it at the moment. This part of the Ross Sea was first sailed into by Captain James Ross in 1841, and his 2 ships, the Erebus and the Terror. And of course, if the Name Erebus rings a bell with you, of course the active volcano of Mount Erebus is named after it on Ross Island, which hopefully we'll see later today. Not many people know there is actually a second, or there's actually 4 mountains on the island. The second largest is Mount Terror, which is named after his 2nd ship. Yeah, Mount Minto has a very Australian flavour to it because it was a group of Australians in 1988, in the bicentennial year, who eventually summited Mount Minto. And there'd been numerous tries previously, mainly from Norwegians in actual fact, and it had never been summited. So in 1988 there was a group of underfunded mountaineers who came down here in a 60-foot steel-hulled ketch, and they sailed across the Southern Ocean, and they were led by a gentleman you've probably heard of called Greg Mortimer. And of course Greg Mortimer owns Aurora Travel or Expeditions these days, and there's a ship named after him. And he was with 5 others called Lincoln Hall, Jonathan Chester, Lyle Cross, Glenn Singleman and Chris Hilton, and they landed at a place called Cape Hallett in the Ross Sea, which is the where an abandoned British base is, and then they headed up to Mount Minto.
Hello folks, and welcome to the mighty Antarctic. I'm sure you're all getting some views through the cloud. Right, we're just starting to burst clear of some of this cloud, folks, and certainly on the right hand side you're seeing a beautiful stretch of coastline, a lovely volcanic mountain. I'm pretty sure that's Mount Melbourne on the right hand side of the aircraft. There are crevasses coming down the slopes of that mountain. I'll talk a bit more about how crevasses form as we get further on. The clarity gets a bit clearer, but there's glaciers coming alongside it. We're approaching the area where it's called Terra Nova Bay, and that again, as Greg mentioned, a lot of these areas got names based on the ship that was the leading ship of the expedition. So this is Scott's Terra Nova, 1910, 1911, so Terra Nova Bay, and we're seeing a small floating glacier tongue. Hopefully that'll come up on the left hand side of the aircraft shortly. On the right hand side we're looking up the glacier that disappears off into the clouds, some crevassing, some beautiful flowing glaciers coming down through the mountains, a wonderful escarpment where the big East Antarctic ice plateau is butting up against the Transantarctic mountains and trying to find ways through the valleys down towards the coast. So welcome folks to a bit more clarity, a bit more viewing, some lovely things to see. We'll describe them as we get them out either side of the aircraft. We're approaching the area where the Italians have a research station, where the Germans have a research station, where the South Koreans have a research station, and as we speak there should be Chinese building a new research station which they haven't given a name to yet, or they certainly haven't revealed it yet, but it's on a place called Inexpressible Island, and with any luck we might be able to see each of those stations coming up on the left hand side of the aircraft shortly.
So folks, this is a treat because the cloud has actually dissipated earlier than the the meteorologist had said. And as Mike said, that's Mount Melbourne out on the right-hand side now. It's one of the very few nearly perfectly conical ex-volcanoes in the world, like Ruapaya, Etna, etc. So on the left-hand side of the aircraft, Terra Nova Bay that Mike just mentioned, named after the Scots ship, the Terra Nova. And we're just in close where the water meets the land. We're looking at the moment for Jangbongo, which is a South Korean station. It's in the shape of a starfish, and it's turquoise blue. If you do go straight across the bay now to the rocky outcrop, and you're looking go further, you're looking straight down a new runway that's being built by the Italians, come back to the coast, and that's their base. Now, their base is very hard to see. Most people paint things very bright colours here. The Italians have basically painted their base brown on brown rock. Both these bases are all year round bases, and which means they are manned the whole year round. Scientists increase the population quite considerably during the summer months, and then basically they all have very small maintenance teams in the winter months. On the left hand side you'll see a just forward of the aircraft, you'll see in Terra Nova Bay a horseshoe shaped bay. If you follow the coast right to left, the Italian base of Mario Zucchelli is right on the tip of the rocky outcrop you can see there. Now, coming right underneath us now, which you obviously can't see, is the runway that the Italians are building to be an all year round runway. So look forward, just forward, and the pilots will keep it at about this distance now, not to get in too close. And great view of Mario Zucchelli.
Thanks, Greg. You actually, on the right hand side, you should get a good view at the moment because the sun's gleaming off the side of the buildings. So if you follow the island right out towards the left hand side, and you'll find two sort of look like smudges. The middle smudge right beside a little horseshoe harbour bay in there is where the station is. So it's directly opposite at the front of the aircraft, so towards the back it should be directly opposite shortly. They have done a huge amount of work. They sent in a group of 27 people to do a lot of construction on the station this season, so they've opened up that big red container that Greg was talking about, and they're building a station that's sort of based on a design around the Southern Cross. So it has a long axis and a shorter axis off either side of it, and right now we're almost looking directly along the main axis. So if you look at the tongue of sea ice that's floating out across the water, follow that over to the ice cliffs. The first smudge of moraine is not the place you need to be looking. You need to look across that little round horseshoe harbour, and on the right hand side of that little horseshoe harbour you can see the station and even some areas going up on towards the plateau where there's a road and some materials have been moved. And right at the moment we're getting sunlight gleaming off the roof of the new building. So they sent 3 ships down. They sent down their 2 Chinese icebreakers, both named the Snowdragon, Snowdragon 1, Snowdragon 2, which in Chinese is Zhulong. And they also sent down a cargo ship to bring down a whole lot of cargo, and the 27 expeditioners who are going to build this new station. So as I said, at this point in time, it's not been given a name yet, But the history of the Chinese research stations in Antarctica is quite interesting. They are now a signatory to the Antarctic Treaty System. They were never involved in the original setup in the early 1950s, but they certainly had their first Antarctic Chinese expedition took place in 1984, and they built over on the other side, the South American side of the Antarctic, they built Great Wall Station in 1985, and that's their first wintering station on King George Island in the South Shetlands. We're doing a turn around now, swinging around to our left, where you can see the magnificent Drygalski ice tongue projecting right out into the Ross Sea. It's got a very, very unusual shaped edge where the ice cliffs from time to time collapse, because what's happening here is the glaciers come down to the coast and then it started to float out over on the sea itself. And with the sea there's very little friction, there's nothing like the bedrock friction the glacier had inland, and so it spreads and moves very quickly out and thins as it goes, and so it has weaknesses. It's bringing crevasses down from the highlands, and those weaknesses are being worked on by tidal forces and wind and waves and storms, and it breaks off icebergs from time to time. But it's a very rapidly moving glacier, and that's the reason it's able to float out over the ocean and remain its integrity for quite a few kilometres out to sea. Its thickness at its floating edge right at the front is probably 30 metre high ice cliffs, and if you follow the 10 to 1 rule, that means the actual ice shelf itself, or the floating ice tongue itself, would be about 300 metres thick in that area. Where it first came off the continent, the ice would have been probably 2,000 metres thick. So you get an idea of how fast it's spreading out and pushing out over the ocean and being affected by the wind and the waves and the tides that are flexing it all the time. So we have some beautiful Piedmont glaciers on the right hand side, where the glaciers come down to the coast and then spread out. On the left hand side, although we're banking away a bit at the moment, you probably can still crane your neck and see that wonderful Drygalski ice tongue. And that's one of the really tough areas that Mawson, Edgeworth, David and Mackay had to traverse across on their journey inland to find the South Magnetic Pole. And I think it took them something like 10 days to cross the Drygalski ice tongue area and gain access to the plateau and make what was supposedly relatively easy access toward the South Magnetic Pole from that point onward. So a really historic area to be in, and some wonderful sights to be seen. Out on the left as well, there's a lovely tabular iceberg coming up. There's some beautiful sea ice. We're very late summer now, so most of the sea ice has broken up and dissipated and melted, but because the Ross Sea embayment goes so deep and so far south, it extends to about 78 degrees south, the ocean and the temperatures remain cool enough for some of that sea ice to survive late into the summer. And you'll be able to see some beautiful swirls in it, you'll be able to see patterns, and those patterns are caused by the surface water currents and the winds that are blowing across the sea ice, and you'll see some lovely shapes. They should mostly be semicircular. There's two sort of main types of ice. The ice that grows out directly from the continent and is stuck fast up against the coast, and quite surprisingly it's called fast ice. It doesn't mean it moves fast, but it means it's moving, or it's stuck. It's not moving at all, it's stuck close to the coast, it's stuck fast. And as we come up on the right hand side, if you look down, you'll see some very rectangular pieces of broken ice, and that's very typical of the way fast ice breaks up, because it forms more slowly, more smoothly, more regularly than the pack ice out in the open ocean, being sloshed around by wind and waves. It tends to be a more uniform sheet, so that when it breaks up, it has these very rectangular, angular edges, whereas the open pack ice is much more rounded. So those on the right hand side look down very close to the shoreline. You'll see some broken up fast ice. Those on the left hand side enjoy the beautiful views of the swirls and the swathes of sea ice that are floating out as the free pack ice in the Ross Sea.
So folks, just coming on the right hand side now, look out and you'll see the Olympus ranges. just forward of the aircraft, and we're going to fly past and then start doing some circling. The second valley is the Wright Valley, which is the largest valley in the dry valleys. And then if you look further forward is the Asgard Mountains. So this is actually unbelievable, and there's a lot of conjecture amongst scientists exactly why there's no snow and ice in this area. But really it is shielded from the winds and the ocean by the valleys themselves, and hence the snow and ice just doesn't actually reach the valleys. The longest river in Antarctica, which you're just starting to look up the Wright Valley on the right hand side now, is the Onyx River, and it's 32, nearly 33 kilometres long, and believe it or not, when it does flow, it flows away from the ocean, not towards the ocean. Now they've found mummified seals in the valleys here, and they have no idea how the seals got here. Magnificent view right up Wright Valley, the Wright Valley now, and
Hi folks, Mike again. As Greg said, we will be doing a figure of eight so everybody gets a chance to see this, but just describing out the right hand window, we're looking at the Wright Valley, and there's a snaking line along the valley floor, which is the Onyx River that Greg mentioned, and it flows inland. It only flows in summer, of course, because it needs the summer melt to come off the Piedmont glaciers along the coastline. And it flows all the way for nearly 50 kilometres into the lake, which you should be able to see in the centre of that valley now, which is known as Lake Vanda. And Lake Vanda is a very special lake. It has an ice cover on top of it, which you can see quite clearly. Just around the edges is a blue moat, but then there's white ice covering the bulk of the lake, and that's caused by the fact that it's got freshwater lid that sits on top of a very salty base water. Now, the base water comes from the Onyx River flowing in and bringing in some minerals, and then as the water evaporates away, those minerals are left behind and make the lake very salty. So at depth it's extremely dense and the water stays at the bottom, so it doesn't mix very well, and the top is fresh water which freezes much more easily than the salt water. So that's a perfect view straight along the Wright Valley across Lake Vanda, and in the distance you can see a rectangular tongue of ice coming down, flowing off the plateau. That's the Upper Wright Glacier, and it doesn't get any further into the valleys, as Greg was mentioning, because of the winds, the dry winds that blow across the top and evaporate the surface away and don't allow it to flow further down into the valley itself. So at the right hand side, a very, very clear view of Lake Vanda. One of the things that happens with Lake Vanda is that the ice at the surface gets ablated by the winds and the sun that falls upon it, and so that as that happens, more ice grows at the bottom of it's about a 4 metre thick layer of ice, and the bottom of that ice continues to grow while the surface evaporates away, and as a result the ice crystals in that lake, or at the top of the lake, are actually quite vertically channeled, and so they allow the sunlight to be filtered directly down into the depths of the lake. And surprisingly, even though the surface temperature out here might be -2, -3 degrees Celsius, at the bottom of the lake the temperatures are something like +25 degrees, and that's due to the different density and due to the ice crystals with their vertical alignment channeling the sunlight directly down to the great depths of the lake. This is far and away the best views I've ever had of the dry valleys. You can see all the glaciers in the corries on these mountain ranges trying to work their way down towards the valley, but they get nowhere near the bottom of the valley. They're probably only moving a couple of metres per year. They're very, very slow moving, very small amount of ice feeding them from here, because the ice out on the right-hand side is not coming from the plateau. It's coming from just local snow that's falling and accumulating as a result of weather pattern events that are occurring in the Ross Sea. On the left-hand side of the aircraft, of course, you'll be seeing the plateau trying to work its way down through the valleys in the Transantarctic mountains, occasionally finding places to come in, but again not being able to extend very far into the valleys, because what tends to happen is as the cold winds that pull on the Antarctic plateau behind the mountains starts to find its way down the valleys, it descends, and in descending it's compressed, it warms up, it's a warmer wind that blows through the dry valleys and evaporates all the snow and the ice that's trying to come down via the glaciers. So a magnificent, simply magnificent view of the dry valleys, whichever side of the aircraft you're on. We're doing figure of 8, so whatever you haven't seen yet, you will see shortly. You'll see the plateau at the moment on the left trying to work its way down through the valleys, in the mountains, into the dry valleys, and on the right you'll be able to see across McMurdo Sound to Ross Island and the magnificent Erebus, which is going to be one of our future targets on this magnificent afternoon for flying around the Antarctic. Area is because of the warmer and cooler waters, you get a lot of it.
We did promise you that we'd do laps around Volva.
Be able to see some beautiful swirls.
Temporaries. The Germans were down here on the northern coast. They were discovered initially by Scott. Race to get to the pole first, because he had actually Folks, when I first started coming down here as a pilot many years ago, when the commentators put the microphone down and started picking up their own cameras, I figured that was as good as it was going to get, because we don't take a lot of photos ourselves. The silence you've just had, it's good for you. Both Mike and I have got our cameras out the windows, because we have not seen it like this ever before. This is fantastic. I just want you to appreciate just how good this is. Even when you normally get to the dry valleys, there's a bit of cloud, etc. Here. So for those of you interested in the right-hand side, if you can take your eyes off the dry valleys for a moment, you'll see on the you'll see a rather large peak, and that's Mount Discovery. Now, Mount Discovery was named after Scott's ship in 1901 when he made his first trek down here, and that was the Discovery Expedition, and hence Mount Discovery is obviously named after that. And it's a 2,600 metres, so it's not a small mountain, but it's not a big mountain by comparison. We're now accelerating. We're leaving the dry valleys, and we're heading towards Ross Island and Mount Erebus and McMurdo. And it's absolutely magnificent out the front of the aircraft. We are led to believe that there's a tanker alongside in McMurdo, which to see a ship down here is very, very unusual. And if we seem to get excited for seeing a ship, well, it is quite unusual. It's the Arcadia Trader, and it's a tanker vessel, and Mike's actually feeding me this at the moment. He should be saying it's 180 metres long, 38,000 tonnes. And just a moment ago we went over Cape Evans, which is where Scott left from in 1910. Absolutely magnificent view of Erebus out to the right now. Remember what I said of the illusion. Now we're turning. It appears that we're below the level of the crater. We're at 18,000 feet at the moment. That crater is 12,600 feet. It is an absolute optical illusion. Now normally you can see steam coming out of the crater. I can't actually see any today, but as has been said before, this is the only active volcano in Antarctica. Whilst Mount Melbourne, which we went past before, has some geothermal activity inside it, it's still regarded by volcanologists as dormant. This is the only one recognised as active at the moment. Now, out on the left-hand side is another mountain, and that's Mount Terror. And most people don't know much about Mount Terror because it's much smaller than Erebus. But there's actually 4 mountains on the island, and right at the moment there's quite a small mountain right underneath us, which is Mount Terra Nova. So, but the 2 large ones are Erebus and Terra, named after James Ross's ships. So folks, right at the moment we're just flying between Erebus and the bases of McMurdo and Scott, and if you look out also to the left right now, you can actually see Williams Field in the ice, and you can see the buildings associated with it. You can follow the roads back to the bases. Now, we are going to turn left and put the left wing down, and that will put better view of the bases. But if you basically see the little bit of little granite hills sticking up out of the ice, on the left hand side of it is Scott Base, and on the right hand side in the little cove is McMurdo. Now Mike mentioned the Polar Star cutting a channel into McMurdo, and you can actually see the channel the icebreaker cut very, very clearly. So see the channel in the ice and follow it right to left, and that will lead you straight to McMurdo. Keep your eyes on the spot where it reaches that granite mountain, and eventually McMurdo base itself will come into view. As we said, there's meant to be a supply tanker tied up at the wharf there, so there's no reason to suspect that it won't be there. Under the Antarctic Treaty, there is no military activity allowed in Antarctica, except for resupply. And in actual fact, the base of Scott is resupplied by the New Zealand Navy. So when I was down here last year, they had one of their resupply frigates tied up. They're resupplying Scott base. Now, McMurdo is the largest of the bases in Antarctica. It has the capacity of holding 1,300 people. It has the only 2 ATMs in all of Antarctica, which are operated by Wells Fargo Bank. It is a little city. One of the things that is not well known, when in the 1950s, when McMurdo was first set up, it was powered by a nuclear reactor. And that was an old cumbersome nuclear reactor. And of course, under the Antarctic Treaty, when it was signed initially in 1959, there is no nuclear activity allowed in Antarctica, and it was just taken apart and taken away.
Yes, as Greg mentioned, McMurdo is a very interesting place. It's the largest research station in the Antarctic, and over summer there's up to 1,000 people or more populating the station, and over winter there's a couple of hundred just to keep the station running and to run a bit of scientific research. That channel in the ice has been cut very, very cleanly by the Polar Star, and while the ship's still at the ice wharf there, it will actually move up and down through that channel and keep it open just in case some of the ice tends to, on the change of tides and winds, move back in and block the channel up. And the ships that do the resupply and the ship that does the resupply of the station fuel, neither of them are icebreakers, so they require the fully ice strengthened Polar Star to come in and cut the pathway for them. And then they follow it in and follow it out. So the icebreaker would lead the tanker out when it's finished resupplying with the fuel, just as a couple of weeks ago it led out the cargo resupply vessel, which was named the Ocean Gladiator. And again, it's about a 160 kilometre long ship, and it would have brought in some 400 or 500 units of cargo, which would be 80% or more of the annual resupply. Some of the resupply will come in via the aircraft on the runway strips out on the McMurdo ice shelf, but most definitely the greater bulk of the cargo comes in via the ships. And as I said, as they're not ice strengthened, they are led into the station by the icebreaker. And I believe they probably, depending on what ice conditions were like out around Cape Adare, they might take them all the way up to the northern end of the Ross Sea and then lead them out through the sea ice, the broken sea ice there as well, because they're only ice strengthened or slightly ice strengthened ships, and they don't have the ability to break or push too much ice aside.
2 ice runways here that service Scott base and McMurdo base. Williams Field is the major base here. It's a floating ice runway. It's all year round. It's very, very rare that they'll attempt a winter landing, though it was done 2 years ago for a medical evacuation. And the second ice runway is Phoenix Field. These are ice shelf runways as opposed to blue ice runways. The runway at Casey Base is a blue ice runway, which is built on a glacier, and that ice at Casey, which is called Wilkins Field, after Sir Hubert Wilkins, a very famous Australian explorer, that ice is 300 metres thick, so landing a jet on it is certainly not going to break the ice. Excuse the pun.
There's a bit of plume coming out of the crater of Erebus at the moment, so if you're on the left-hand side of the aircraft, you're getting a perfect view of the little plume coming up out of the crater and the beautiful sunlight reflection on the water in McMurdo Sound. So a few more facts about McMurdo. The ATM business, that's quite right. And why do they even need an ATM? Because they've got bars, they've got a gift shop, people can buy souvenirs and clothing there, they can even buy some DVDs and movies to play at times. The good news, there are no, I repeat, no McDonald's or KFCs at McMurdo, which is fantastic.
As I said to you earlier on the trip, I like this part of the world because this is where everybody left from. Scott, Shackleton, Armiston. Now, Armiston actually left from the Bay of Wales, which is out to the right and further along, and he was very, very lucky that in that particular year, 1910, 1911, the Bay of Wales was actually clear of ice. And so that gave him a distinct advantage over Scott, that he was some 90 kilometres closer to the pole by departing from the Bay of Wales. And the funny thing is, even though Scott had received a telegram at the last minute that Armiston was heading for the pole, he had no idea that he was actually down here and where he was. So I mentioned Victor Campbell, his second in command, and after Scott had set up his base, Victor Campbell took the Terra Nova, the ship, and headed east to find a landing spot and do some research. And he ventured into the Bay of Wales, and lo and behold, came across Armiston and his expedition team. So whilst Scott will claim it was never a race, he was here for scientific research, and he was, and reaching the pole was secondary. It was 100% Armiston was down here in a race.
So on the right hand side you're seeing some little moraine lines that are coming down just off the edge of the ice shelf. You're seeing some fast ice. You can see that white lines in front of you. There are some lines across it, particularly on the right hand side. I can't see out the left hand side at the moment, yes, but you'll see some lines going across it, and they're where the tide's flexing it. They're known as tide cracks. They're probably filled in with snow. And just out the front of the little edge of the ice there, you can see all these angular pieces of ice, and that's the fast ice that's broken away from the coast and now becomes part of the open ocean pack ice and will break up before the season finishes. So about now we're at the absolute minimum of the sea ice for the season. Perhaps it'll become a little bit less if there are a few storms come through, and almost all the ice, the sea ice in the Antarctic, is 1 year old. There's very few places apart from the Weddell Sea and in some sheltered inlets and behind some islands where the ice lasts longer than 1 year, which means that most of the ice down here only ever gets to a thickness of about 1.5 to 2 metres. In the Arctic you've got an ocean basin surrounded by continents, and so the sea ice that forms there is what's known as multi-year ice, and it can grow to 5-6 metres thickness and last 10 to 15 years before it eventually moves out of the Arctic gyre into the open ocean and then melts and breaks up. So Antarctic ice in general 1.5 to 2 metres thick, and in general only about 1 year old. Quite significantly different to Arctic ice. One of the problems it caused for the early explorers and the ships coming down here is because what happens when the sea freezes is it does its best to eject all of the salt it can out of the water, but it can't get rid of all of it. So little crystals of ice form in the water once it gets cold enough, and then the whole thing starts to coagulate together to form little pancakes and little ice flows, which grow into bigger ice flows and form the vast pack ice that fills the ocean around Antarctica through most of the winter. But the salt only goes slowly out of the ice, so it's too salty to drink. If you melt Antarctic 1 year old sea ice and try to drink the water, it's far too brackish. In the Arctic you can use multi-year ice because over the years the brine drains further and further and further and deeper into the ice, and so if you use the snow and ice from the top surface of multi-year old Arctic ice, then the water is quite drinkable. And that meant that when the early explorers came down here and wanted to resupply their fresh water, they actually had to go and take glacier ice, and that usually meant getting near an iceberg and taking ice from the iceberg, or if they were fortunate enough that some ice cliffs had come down from the iceberg and broken up some pieces into the water around it, they could collect the pieces and then turn that into their drinking water. We sometimes do that on our expedition ships out of South America. We collect some ice beautiful ice with air bubbles in it, and it snaps and crackles and pops in your drink when you take it to the bar. But the trick is make sure that if you've scooped up a piece of beautiful glacier ice, which is pure freshwater ice from the ocean, wash all the ocean water off it first, because if you just melt it and let it have the outer layer of salt on it, you'll end up ruining any 50-year-old scotch that you're trying to enjoy in the bar that evening, talking about your adventures for the day.
I was asked earlier about wildlife down here. Now, obviously, at 18,000 feet, we won't see any wildlife. And, the trick question, of course, is how many polar bears will we see down here? And, of course, there are no polar bears in the Antarctic. Where's the only place in the world a polar bear and a penguin will meet? And that's in a zoo, because there are no penguins in the Arctic. In actual fact, all 17 species of penguin, bar one, are all located in the southern hemisphere. And the only exception to that is the Galapagos penguin. And of course they reside in the Galapagos Islands, and they're only just over the equator really.
And speaking of amazing, we're approaching very quickly now back to the Drygalski Glacier tongue. Those on the right hand side looking out to the ocean have got wonderful views of the broken up pack ice. They've got a magnificent, really flat edged, elongated tabular iceberg. You might wonder why that the sea ice looks like it's got a very edge to it on the far side towards the Drygalski ice tongue, and it has, because there'll be winds coming across the ice tongue which are pushing the sea ice together and compacting it up into a very, very firm edge that's running along the side. And if this was late enough in the season, that would be where ice would first start to freeze up again and form the next year's winter sea ice. But that's almost certainly not going to happen. There'll be storms and other things come through here and remove most of that sea ice before it can actually start to coagulate together and freeze together and form a new season's cover. So extending, as Greg said earlier, out about 70 kilometres from the coast, and that gives you a really good idea of the perspective of the distances in the Antarctic. So you're looking from where we are, we're very close to the edge of the coast, and we've got a clear view of the end of the ice, the glacier tongue, and it's 70 kilometres away. And it's about 15 to 20 kilometres across this glacier. And it was on here earlier, I think I mentioned to you that when Mawson was finally recovered from his South Magnetic Pole journey by the ship with John King Davis, that he fell into a crevasse. Well, earlier on in going across this glacier, David fell into a crevasse, and Mawson at the time was inside his tent, and he was developing some of the photography and films that they'd taken, and he was he was using a dark room bag, and he was developing some film, and he was concentrating very hard to make sure he didn't ruin the film. And David was calling out to him, and he called out a couple of times, and Mawson pretty much ignored the first couple of times until the third time David made it fairly clear that things were quite precarious. And when Mawson poked his head out the tent, there was David virtually by his fingernails hanging onto the edge of a crevasse, and he very quickly helped haul him out. So pretty infamous area, this one, and something that really belongs in the annals of the Antarctic history. The great names of the Antarctic, your Mawsons, your Shackletons, your Scotts, your Amundsens, and you can add many, many, many more. And as interesting characters go, Francis Bickerton is one of the best, the old treasure hunter pirate that he was.
If you look out on the right hand side now, you can see the Transantarctic Mountains, and there's quite a lot of cloud there, but Mount Minto is to our right, whereas we came in over the top of Mount Minto. So these are actually a different mountain range altogether. This is the Alamein range inside the Freiberg Mountains out to the left now, and they're regarded as just a slightly different range to the Transantarctics. So as you can see, nowhere near as high, but nevertheless still spectacular. And as you move westward along the coast, and we're not far from the coast now, it becomes flatter and flatter until eventually there are no mountains at all, and it's just the ice shelves, etc. I'll sign off myself. I'm sure you're sick of the sound of our voice. Hopefully we've taught you a few things or given you a little bit of information about this place. Antarctica gets into your skin. Once you've been here once, you'll want to come back again. I know a lot of you on board have been down here by ship, and the ships give you one perspective. This is a completely different perspective, as I'm sure you'll agree, that you just don't get from a ship. As I said earlier, this is on just flying here, let alone the ships. This is my 31st time down here, and I never get sick of it. The one thing that Antarctica needs are friends, and the Antarctic Science Foundation is obviously a friend, but just by coming down here and just learning a little bit more about this fabulous, pristine continent, you have actually become a friend of Antarctica. And this place is described as more isolated than the International Space Station, because it is actually harder in the middle of winter to get someone out of Antarctica off the bases than it is to get someone off the International Space Station. So you're now a group of a very small group of people that have experienced this great white land. Thanks for coming with us. Tell your friends what a great place it is, and we hope to see you down here a few more times. I know there's many people, or a few people on board I should say, that have done this flight on multiple occasions, so hopefully we'll all see you again. Thanks for listening, and good afternoon.
So initially the forecasts weren't great, but we got a great view of Mount Minto and Mount Sabine before tracking down over the Drygowski ice tongue. Saw all the bases in Terra Nova Bay, over the dry valleys, across the Jewel in the Crown Erebus and Mount Terra. Hope you had a great day.